this video, we're going to go over the KutaSoftware Infinite PreAlgebra free worksheet, inequalities, and their graphs. And these are going to be single inequalities, so we're dealing with just a single number line. And for the first part of our directions, we're going to draw a graph for each inequality. So let's talk about inequalities quickly. We know that an equality is an equation where we have an equal sign, meaning that the left side is equal to the right side. Now for an inequality, there are 4 different symbols. We could have a greater than symbol, a less than symbol, a greater than or equal to, which is the same as the greater than symbol, just with a line underneath, or a less than or equal to. So those are 4 potential symbols we're going to have throughout this worksheet, and we're going to talk about the less than or equal to symbol and number 1. So let's look at number 1. Number 1 states that our variable x is less than or equal to a value of 1. And how I remember that this is less than or equal to is think about Pac-Man or Miss Pac-Man, or even like an alligator chomping on some food. What this is trying to do is going to eat the larger number. So if our Pac-Man or our alligator is trying to eat the larger number, that means that x is going to be smaller than 1. That's the way that you can remember that this is a less than or equal to symbol. So x is less than or equal to 1. What does that mean? Well, first of all, we're going to start by locating that number 1 on our number line, and we're going to circle it. So finding 1 on the number line, let's go ahead and circle it. Now we said that x is less than or equal to. So knowing that x is less than that, we're going to shade. And we either need to shade to the right or to the left. But if x is values that are less than 1, x could be 0, x could be -1, x could be -7, and so on. X will not be those numbers over there. So we're going to be shading to the left. And when I say shading, we're just going to draw over top of this number line as best we can, showing that x can be all these values that are in red, and we're going to put an arrow showing that it continues on. Now this would be fine, and we would be done if this was just x is less than 1. But x could also potentially be 1 because we have that less than or equal to sign. So because it's less than or equal to, where we circled around that 1, x can be that value, so we just shade in that circle. So again, whenever you see these less than or equal to or greater than or equal to with the line underneath, we need to shade in the circle. If it's just less than or greater than, we leave it as an open circle. So remembering that, let's continue on now to number 2. In number 2, we have that m is greater than a -2. How do I know it's a greater than symbol? Think about this. If we were to draw our Pac-Man or Miss Pac-Man, it's going to try to eat the larger value. So m is larger than -2, so m is greater than -2. But I'm going to start just like I did in number 1 by finding that -2 and circling it on the number line, which occurs right here. So circling that -2, now we have that m is greater than -2. So what's a value that's bigger than -2? Well, -1 is, 3 is, 7 is, but nothing on this left-hand side. So we're going to be shading to the right. So m could be any of those values that I just shaded in, but can m be a -2? No, it cannot, because the equal to is not part of our inequality. Therefore, we're going to leave this circle as open. And there we go. Let's move on to number 3. In number 3, we have that x is less than or equal to number 4. Again, I know it's less than or equal to because if I was to draw Pac-Man or Miss Pac-Man, and I'll put the bow in her head, you can see that they're eating that larger number of 4. So 4 is larger than x, so that means that x is less than or equal to 4. So starting with finding 4 on our number line, we're going to circle it, Then we're going to shade in our x values, which if x is less than or equal to 4, a number that's less than 4 is 3, 2, 1, all of these numbers to the left. So we're going to shade them all in. And don't forget to draw our arrow at the end, showing that that continues on, because x could be -8, and that's not on the number line, but it could be it. So we're going to include that arrow towards the end. One last thing, it says that x is less than or equal to, so we know that this circle needs to be filled in because x can be that value of 4. Let's move on to number 4. In number 4, we have that m is greater than -6. So let's start this time by finding -6 on the number line, which occurs here. Now, how do I know that this is a greater than symbol? Again, if we were to draw a Pac-Man or an alligator, looks more like a gecko or something. Doesn't quite look like an alligator, but you get the concept. It's going to eat that larger value. So m is greater than the -6. And if m is greater than -6, the values it could have would be, well, -5 is bigger than -6. 4 is bigger than -6. Is -7? No, -7 is not. So I know I'm going to be shading to the right of that circle that I just drew. And is the circle that we circled around -6 filled in, or is it empty? Does it look like this or this? It's going to be empty. So we're not going to fill it in because m cannot be -6. It needs to be greater than, but it can't be equal to it. Let's move on to number 5. In number 5, we have that -5 is greater than or equal to a. So because -5 is bigger than or equal to, greater than or equal to a, we're going to circle that -5. And because I know it's greater than or equal to, I'll go ahead and fill this in now so I don't forget to later. Now, which way are we going to shade? To the right of that filled in circle or to the left? If -5 is greater than or equal to a, that means that a is values that are smaller than -5. And those are going to be values to the left. So we're going to be shading in to the left of -5. And if you ever get confused on which way to shade, pick a value. Let's pick the value of -2 for a. If a was -2, we have that -5 is greater than or equal to -2. Is that true? No, it's not. So because that's not true, we know we don't shade in on that side. Let's continue on to number 6. In number 6, we have that 4 is greater than or equal to x. So finding 4 on our number line, we know that x is values that are greater than or equal to. So we're going to fill in that circle because we have that equal to. And we're going to be shading to, which way? Think about it. Let's try plugging in a 5. Is 4 greater than or equal to 5? No, it's not. So we don't want to shade to the right. We want to shade to the left. X could be values of 3, 2, 1, and all of those negative values as well, because 4 is greater than or equal to x, meaning that 4 is larger than all of these values, which represent my variable. Let's move on to number 7. In number 7, we have that -2 is less than b. So locating -2 on our number line, are we going to fill it in? No, we're not, because we don't have less than or equal to, we just have less than. So again, thinking about it, b is that larger value. So because b is larger than that -2 is less than b, we know that b is going to be values that are larger. So b can be all the values to the right of -2. So if we were to plug in 0, 0 is indeed bigger than -2, or reading it, -2 is less than 0. Let's move on to number 8. In number 8, we have that 1 is greater than x. So I'm going to locate 1 on my number line, circle it, and if 1 is bigger than or greater than x, that means x has values that are smaller than 1. So we're going to fill in all the values to the left of 1, and that is x. Now quickly, I want to note that we could also write 1 greater than x a different way. We can write it as x is less than 1. As long as that inequality is pointing towards the correct numbers or correct variables, we can write the inequality by switching the left and right side. So you see how, again, the opening of our symbol is going towards the 1. Here, the opening is going towards the 1 still. So this, which originally reads that 1 is greater than x, can also be read as x is less than 1. So if you ever get confused, you can rewrite it and say it in a different way and try to graph it according to that. Either is the same and is going to produce the graph we just drew. For now, let's move on to number 9. In number 9, this one's a bit confusing because it says that negative r is less than or equal to negative 2. We don't want to solve for a negative r, we want to solve for r. So just like with an equation, if we were to have negative r is equal to a negative 2, what do we do to solve for r? We would divide by our negative. So dividing by a negative 1, dividing by a negative 1, we would get that r is equal to negative 2 divided by negative 1, which is a positive 2. So the number we're going to want to circle is a 2. However, this was for an equation. We want to do this for an inequality. So let's rewrite this now, solving out for an inequality. We have negative r is less than or equal to a negative 2. Same way with an equation, whatever we do to the left-hand side, we do to the right-hand side. So I'm going to divide by a negative 1. Negative r divided by a negative 1 is going to be a positive r, and negative 2 divided by a negative 1 is going to be a positive 2. But what exactly happens with this inequality? Because we divided by a negative, we need to flip the inequality. So all we're going to do is make it point the other way. So as opposed to a less than or equal to symbol, it's going to be a greater than or equal to symbol. And again, this is the case when we multiply or divide by a negative 1. We flip the inequality. So now we're going to graph this inequality, which is the same as this one. R is greater than or equal to 2. We located our 2. R is everything that's greater than or equal to. So we're shading to the right and filling in that circle. And if you want to double check these values, think about plugging some values in. Let's say 3. If we were to plug 3 in, for r, we would get that negative 3 is less than or equal to negative 2. Is that true? Yep, it sure is. What about 7? If I were to switch this and plug in a 7 for r, we would get that negative 7 is less than or equal to negative 2, which is also true. So you can see that we're finding those values for r, and when we plug them back into our original inequality, they hold true. Or we could look at this one, plug them in for that one, and it's the same thing. Let's move on to number 10. For number 10, again, we have a negative with our variable, which we don't want. We don't want to solve for negative n, we want to solve for n. So I'm going to write this as 4 is less than or equal to a negative n. And then we're going to do what with this inequality? We're going to divide or multiply by a negative 1. Our left-hand side, 4 divided by negative 1 becomes a negative 4. And our right-hand side, negative n divided by negative 1 becomes a positive n. And what do we do with our inequality? We flip it. Because we divided by a negative 1 or multiply by a negative 1, we flip that inequality. So our less than or equal to now becomes a greater than or equal to. So it's just pointing the opposite way. Now graphing this, we're going to find negative 4, circle it, and if n is values that are less than or equal to negative 4, because negative 4 is greater than or equal to n, meaning that negative 4 is larger than our n values, we're going to be shading to the left, and it also potentially could be equal to negative 4, so we're filling that circle in. Let's double check and plug in some values. What if we were to plug in let's say a negative 6? Well, plugging in a negative 6 over here, we get that negative 4 is greater than or equal to negative 6, which is indeed true because negative 4 is that larger value. If we were to plug a negative 6 in for n over here, we would get that 4 is less than or equal to a negative 6, because this negative is outside of n, and we're plugging in negative 6 for n. And negative, or the opposite of a negative 6, is going to be a positive 6. So we get that 4 is less than or equal to a positive 6, which is true. So you can see that this inequality checks out. Let's move on to our next problem. In number 11, we have that negative n is less than or equal to negative 5. So without even working out the inequality by division or multiplication, let's just think about this. Let's choose a value and plug it in for n. Let's say we'll choose negative 4. If we plugged in a negative 4, we would get negative 4, or the opposite of negative 4 is less than or equal to negative 5. So then we would get 4 is less than or equal to negative 5. Is that true? No, it's not. So we know that negative 4 isn't going to be part of this inequality. It's not going to be in that shaded region. Let's try this time. Let's try a 6. If we were to plug in 6, we would get that negative 6 is less than or equal to negative 5, which is indeed true. So we know that we're going to be shading in 6. So theoretically, you could do this with all the numbers, but it would be very tedious to work out. But now that we know that a positive 6 is a part of that inequality, we already know which number checks out and which way we're going to need to shade. But let's go back and solve it mathematically. Negative n is less than or equal to negative 5. I can divide or multiply by a negative 1. Let's multiply by a negative 1 in this case, since we haven't done so in the previous problems. Multiplying by a negative 1 times negative n gets me a positive n. Negative 5 times negative 1 gives me a positive 5. I multiply by a negative, so I need to switch my sign. Whenever I multiply or divide by any negative number, I need to switch my sign. So this becomes a greater than or equal to. So if n is greater than or equal to a positive 5, we're going to circle 5, fill 5 in, and we already know which way to shade. Let's move on to number 12. In number 12, we have that 1 is less than a negative x. 1 less than negative x, I'm going to divide by a negative 1 to give me that negative 1 is, flip that sign, greater than a positive x. So I'm going to locate negative 1 on my number line, circle it. I'm not going to fill it in because I have a greater than, not a greater than or equal to. So if negative 1 is a value that's greater than x, that means that x are all the values smaller than negative 1. So I'm going to be shading to the left. Again, leaving that circle open. For number 13, now we're sending in fractions. I have that n is greater than or equal to 3 halves. So there's a couple different ways we can think about this. We can rewrite it as a mixed number, or we can break the number line up into halves and count 3 halves. So here is 1 half. Here is 2 halves, because remember 2 over 2 is the same as 1. Here would be 3 halves, and here would be 4 halves, because 4 divided by 2 is a positive 2. We care about 3 halves, so we're going to circle 3 halves on our number line, which actually falls in between those grid marks, or those marks above our whole numbers, which is okay. We can use numbers in between. That's what the shading is all about. When we're shading, we're saying that it could be any of those numbers, not just the whole ones. And we're also saying that n, our variable, takes on values that are greater than or equal to. So values greater than 3 halves would be 4 halves, 5 halves, 6 halves, and so on. So all the values to the right. And don't forget to fill that circle in. Let's move on to number 14. In 14, we have that k is less than 2. Well, figure out where 2 is on the number line, circle it, and if k represents values that are less than 2, that's all the values to the left of 2. And there we have it. Not filling that circle in, not shading in that point because k cannot be equal to 2. Let's move on to our second page. Now, before we dive into number 15, if you've been finding this video helpful, don't forget to click that thumbs up button and let me know. Also, if you think of somebody else that would find this video useful, go ahead and share it with them. But for now, let's go ahead and dive into number 15. 15 says that our variable p greater than or equal to a -1 1/2, or -1 1/2. So we're going to find -1 1/2 on our number line. So here's -1, but we're -1 1/2. So that means -1 and then halfway in between that and the next negative number. So it would be right here is where -1 1/2 is. So let's go ahead and circle that. And it's also a greater than or equal to, so we'll shade it in as well. Now for this one, it might have been confusing locating this -1 1/2. Remember, this negative is applied to both the 1 and the 1/2. So we can think of this number as -1 plus a -1/2. So we're going -1 and then another -1/2. So to the left of the -1, not to the right of it. Just to help clarify in case you had trouble locating that on the number line. But for now, p is values that are greater than or equal to. We've already filled it in. Values greater than it are going to be to the right. And there we have it. Let's move on to number 16. Number 16 says that n is greater than or equal to +1. So, find +1. Values greater than that are going to be to the right and shade it in. There we go. Number 16 done. Number 17 says that x is greater than or equal to -2. So locating -2, we're going to circle it. Greater than or equal to means that x can be -2, but it also represents all those values greater than -2. So we're going to be shading to the right. On to number 18, we first need to locate where -2 and 1/2 is. Remember, we could write -2 and 1/2 as -2 plus a -1/2. So going -2 on the number line and then another -1/2, we're going to wind up here. And because we say that that value is less than or equal to, we're going to be filling that circle in, and n is going to be all the values to the right because -2 1/2 is less than or equal to my n. So n represents all those values that are greater than or equal to my -2 1/2. Moving on to number 19, we have that -1 1/2 is greater than a -n. Remember, we're not trying to find what -n represents. We're trying to find what n is, a positive n. So we're going to take our -1 and 1/2, which is greater than a -n, and we're going to either divide or multiply by a -1 on both sides. So this is going to take my left-hand side and make it a +1 and 1/2. My right-hand side is going to become a positive n. And what happens to my inequality? Remember, you have to flip your inequality. So it becomes a less than. So now I'm going to find 1 and 1/2 on my number line, which going a +1 and then another +1/2 is going to be right here. Here is approximately where 1 and 1/2 is. I'm going to circle it, and n is values that is larger than that. 1 and 1/2 is less than n. So 1 and 1/2 is the smaller side of n. So 1 and 1/2 is less than n, which means we're going to be shading to the right, because n represents those values that is greater than. If we were to rewrite this our other way, n represents those values greater than that 1 and 1/2, since 1 and 1/2 is less than n. And again, these two inequalities say the same exact thing. 1 and 1/2 is less than n. I rewrote that as n is greater than 1 and 1/2. The opening is the same way, still open towards that n. I just switched what side my variable was on. Let's move on to number 20. Number 20 states that negative 1 and 1/2 is greater than or equal to a positive v. So we're going to start by locating negative 1 and 1/2. So going negative 1 and then another negative half, we're going to be roughly here on our number line. And we're going to go ahead and circle that. Now we have that negative 1 and 1/2 is greater than or equal to our v values. So if that's larger than our v values, our v is going to be everything to the left of that, and we're going to fill that circle in because v could be equal to negative 1 and 1/2. And there we have it, number 20. Again, I could rewrite this just by switching my sides. I could write this as v is less than or equal to negative 1 and 1/2. Moving on to our next set of directions, we're going to be writing an inequality for each graph. And for each of these, feel free to choose whatever variable you want to use since it doesn't specify. Let's dive into number 21. Number 21, well, our negative 2 is circled. And which way is the arrow going? It's shaded to the left. So let's choose our variable. Let's make this a. We can say that a is values that are less than negative 2. Not less than or equal to because that's not shaded in, but values less than negative 2. Negative 3 is less than negative 2, negative 4 is less than negative 2, and so on. So a are values less than negative 2. What's one other way I could have wrote this inequality? Well, I could have wrote it as negative 2 is greater than my a values. Because negative 2 is that largest number that's circled and everything else is less than that, so negative 2 is that larger value greater than all my a values. All I did there was rewrite which side my variable fell on, making sure to keep my inequality pointing the same direction. That opening was towards the negative 2. Let's move on to number 22. In number 22, let's pick a variable x. And looking at this number line, what kind of values does x have? X has values that are smaller than or equal to, since it's filled in, smaller than or equal to 5. So x represents values that are less than or equal to a positive 5. We could also write this as 5 is greater than or equal to all of our x values. Either way of writing this is perfectly fine. Let's continue on to number 23. In number 23, let's make our variable b. In this case, we see that negative 5 is smaller than all of our b values because negative 5 is to the left of our shaded region. We're shading to the right. So we can say that negative 5 is less than all of our b values, and it's not a less than or equal to because that circle is open. We're leaving it as a less than. Or writing this the other way, we can say that b is greater than negative 5. b represents all those values to the right, all those values that are larger than negative 5. Let's move on to number 24. In number 24, what value is circled? That's our value of 5, and it's also shaded in. So we know that our equality is either going to be less than or equal to or greater than or equal to. And we can see that 5 is less than or equal to all the values to the right, which let's call this variable x. So 5 is less than or equal to x, or we could write this as x is greater than or equal to 5. Moving on to number 25. In number 25, all our values are shaded to the right of negative 2. So let's call this variable a b. That means that b is greater than, since it's shaded to the right, greater than our negative 2. And it's only greater than, not greater than or equal to, so b is greater than negative 2. Or negative 2 is less than b. For number 26, negative 5 is our number that's circled and shaded in. And you can see that it's less than all of those other values that are shaded in. So if we were to choose our variable, let's call our variable a, we can see that a represents all the values that are greater than or equal to our negative 5. Or negative 5 is less than or equal to a. For number 27, the number that's circled and also shaded in happens to be a positive 1. So all these other shaded values, let's use our variable x to represent them. So x represents all the values that are less than or equal to a positive 1. And it's less than or equal to because it's circled and shaded in. And then lastly, number 28. The number that's circled is that positive 1, same as in number 27, except this time everything's shaded to the right. So if we were to use our variable x again, x represents all the values that are greater than or equal to that positive 1. Again, 2 is greater than or equal to 1, 3 is greater than or equal to 1, 7 is greater than or equal to 1, and this continues on. For example, 99 is greater than or equal to 1, x is greater than or equal to 1. And there we have it. That's our last solution on this worksheet. Again, I'll leave a link in the description below so you know how to access this free worksheet. But as always, don't forget to like, subscribe, and share. Happy learning!